In section 3 we're going to look at a few different kinds of equations, and you don't see these very often, but there's a few tricks to dealing with them when you do. So let's take a look. And so here's one, and you can see that we're trying to solve for the t in this equation, and if you look at it, it kind of looks familiar. If the t plus 4s were just x's, then what would we have? The quadratic equation, x squared minus 6x minus 16. Now I know how to solve that. We factor that. Two things that multiply to give x squared, x and x. Two things that multiply to give 16, 8 and 2. Opposite signs, negative on the larger. Set each of those equal to 0. Solve each of those. And take the t plus 4 and put it back in place of the x's. So there's the trick to solving equations that are kind of like quadratics. Finish solving these, and we've got the two answers. Fraction equations. First thing you need to do is to notice what number does not work for x. Look at the bottoms of the fractions and see if you can figure out what number does not work for x. Remember, the bottom cannot be 0. So x minus 1 cannot be 0. So that means x cannot be a 1. So we cannot have an answer of x equals 1. Now if we do all the steps that we're supposed to do and we come out with an x equals 1, it is not the answer. And so let's do the steps that we're supposed to do. Multiplying both sides by the common denominator. On the left, we use the distributive property. X minus 1 times 1 over x minus 1, and x minus 1 times 5. On the right, we just multiply that out. We cancel the x minus 1's, and we're left on the left with a 1, and we're left on the right with an 11, and the 5 times the x minus 1 can be multiplied out. And so now finish solving this equation is pretty simple. It's a nice linear equation. The 1 and the minus 5 put together, add 4 to both sides, and divide by 5. Now what did we say in the beginning? We could not have an answer of 1. Well, this answer is 3, and that is perfectly fine. See another one, solving for y in this equation. This is like some that we did in the first section, only you got more y's involved. We're going to start off just like in the previous problem. Multiply both sides by the common denominator. On the right hand side, the y minus 3's are going to cancel. On the left hand side, we can multiply that out using the distributive property. Now we're trying to solve for the y, so we need to get the y's together on the same side. So if we move the y term to the other side, and move the 3x to the right, on the left hand side we have two terms that each have a y in them. We need to factor out the y. And finally, to get the y by itself, just divide both sides by x minus 1. We've done something kind of like this before. On the right hand side, 3x minus 2 divided by x minus 1 is still just 3x minus 2 divided by x minus 1. The last sort of problem we want to take a look at is the square root problems. You probably remember to solve square roots, you need to do the opposite of the square root. So we're going to square both sides. Here's what it would look like. Now when you square a square root, there we got a square root that is squared. It just wipes them out. So the square is wiped out, the square root is wiped out, and we end up with just the 20 minus 8x. And on the right hand side we have x squared. Now you recognize this, hopefully, quadratic equation. To solve that, we need to put it in standard form. So we need to move terms around. We need this to say x squared plus 8x minus 20. So here's what it would look like when we move the terms all to the same side. Now we factor. I'll do this quickly since we've already done lots of these. X plus 10, x minus 2. We set each of those equal to 0, and we get x equals negative 10 and x equals positive 2. Now, solving square root equations, we really need to check our answers. So let's take the negative 10 and check and see what we get. When we substitute negative 10 in place of the x, we get 10 equals negative 10. That's not exactly true. So the negative 10 is not an answer. If we try the x equals 2, we get 2 equals 2. So obviously the x equals 2 is the answer. Just want to show you one more of these. The deal with this one is you can't just go squaring both sides. If you look at the left-hand side, I will write a little bit of what you would get if you tried squaring this. Remember, when you're squaring a binomial, you don't just square each of these two terms. You square the first term, you square the second term, that's the easy part, but you also multiply these two and double it. So that would be a negative 2x square root 2x plus 5. And so, if nothing else, you see that if we just did a square on this right here, we get something that is a lot worse than what we started with. And so what we need to do on this one, instead of trying to square both sides right now, is to get the square root by itself. So we're going to rearrange terms. When we rearrange terms on there, we'll move the square root term to the right, move the 5 to the left. That would make it an x minus 5 and a square root of 2x plus 5. And then we will square both sides. And on this one, when you square the square root, it does indeed wipe out the square root and the square. Now remember, when you square the x minus 5, just like we were just looking at, you square the x, you square the 5, you multiply and double. You got 3 terms that you come out with. So do the proper operations. So this is what we would have when we did the square of both sides. And I recognize that this is a quadratic equation. I need to get everything together on one side, move the 2x over to the left, move the 5 to the left, and we can do our factoring. Set each of those equal to 0, solve for x, and check the answers. A 10 checks, and 2 does not.